Okay, so combining two function products. In calculus, you're going to get into this, but we're going to do the basic form of it, okay? So in your advanced function book, they've written it this way. And what it's saying is to find function f, so in other words, f at x, when multiplied by, that's our product sign, for function g, which is our g at x, when the variable is x. That's what we're saying. Well, we know that the variable in f, in function f is x, and the variable in function g is x, so we can do this. As an actual equation, it's pretty straightforward. What we're going to do is just multiply the two equations together. Okay, so as a product, what we're doing is we're taking x squared plus x minus 6, and we're multiplying it by x. Now this is one of the occasions that we can actually simplify. We might start to do a couple where we don't know where to simplify when we're multiplying maybe exponents or logs, but in this one we can. So we know that f by g, when the variable is x, is equal to this. And simplified, when we distribute the x, we'll get x cubed plus x squared minus 6x. So here's our new function. Okay. Now the first thing we want to do, they've asked us to actually just state domains. That's our main goal here. State the domains of our new function. Well, the domain of our new function is going to be relative to the domains of our original functions. So our original function, we'll do f at x, is equal to x squared plus x minus 6. Well, we know that this is what type of function? It's a quadratic function. So right off the top of our head, we don't really have to equate anything because it's not a quotient. We don't even have to know if it's above or below, but let's say this is the function. What's the domain of this guy going to be?
The zeros.
Well, the zeros are just when it crosses the x-intercept. So what are the x values? In other words, when does it exist on the x-axis? Does it ever stop?
No.
Going left, right?
Element of reals.
Yeah, so this is the element. X, the element of the real numbers. Great. Let's do our other one. G at x. G at x is equal to just x. Do you know what type of function that is?
It's the one with the v looking.
This one is actually, it's not a, oh, you're thinking absolute value. Think of it as 1x. In other words, this is a linear equation. This is just something that goes like that. Okay? And I put the arrows at the end to give you an idea again about domain. What is the domain of that?
Same as quadratic.
It's the same as the quadratic. So together, are there any restrictions on either of these domains? So in other words, our new function restrictions, because it didn't really create a quotient or anything, and we actually know we've dealt with these functions. We know this is a cubic function, right? And a cubic function is not going to have any restrictions either. So this one, his domain is also going to be the x is the element of all real numbers, okay? But let's get into something that might be a little more difficult for us. We'll jump to a new page here. And let's say they've given us different equations. F at x, example 3 in your book, is equal to square root of x. Okay, this will give us something different. And g at x is equal to 1/2 x minus 2. Great. Okay. Same question. They've asked us to find the product of f by g when the variable is x. Okay. So we're going to multiply these two by each other, and I think it's actually lowercase, isn't it? F, yeah, by g. Sorry. When our variable is x is equal to, well, that's f at x is just the root of x multiplied by 1/2 x minus 2. Now, we can actually go about multiplying this through and figuring this out. We would multiply our variables together. This becomes 1/2 x times root x minus 2 times root x. So, for instance, we don't have to. Let's say we do. So we get 1/2 x times root x minus 2 root x. Oops, root x. Does this function help us clarify anything? Do we know what this graph is going to look like by looking at this? No, it's not that helpful to us. So what we're going to do is we're going to focus on our domain of our f at x function and the domain of our g at x function, right? Because they all are multiplied together. So a rule, and we're actually going to focus on this one above here, okay? This is the one we want to focus on, okay? Because if at any point when multiplying, if one of these two terms doesn't exist, then the other won't exist. Okay? So we want to figure out when one of them won't exist. So our f at x, in this case, happens to be the root of x, right? Off the top of your head, do you know what this function kind of looks like?
Is it exponential?
This one's not exponential. It actually looks like a quadratic, but just turned on its side. Okay?
Okay.
So we're focusing on the domain. Well, domain deals with the x-axis. So when does this function not exist on the x-axis?
0.
Well, it exists at 0, and it exists to the right of 0
So the negative.
in the negatives. So in this function, it is the element of all real numbers, x with a restriction of x cannot be less than 0. As soon as it's less than 0, we have a negative term, and we can't deal with a negative term when we're doing that. Our other one just was 1/2 x minus 2. This is our g at x. Well, this is just a linear function, so it's going to look maybe something like that. Any restrictions on its domain? No. Okay. But since we've multiplied them together, if we ever have an x value that is going to be less than 0, this part of the multiplication won't exist. So in other words, this new function's domain has to keep that restriction. So the domain of our new function is x is the element of all real numbers such that x cannot be less than 0 for that new function we had, which is f by g, and the variable is x, is equal to root x times. And we just essentially wrote them originally just multiplied together because our distribution didn't help us with anything. Okay, so that is going to be our restriction on that one there. Does that idea kind of make sense?